All right, here goes our first example. This method called sum finds the sum of consecutive integers starting from 1 and stopping at n. N is a long, that's what the method takes in. It returns a long, which is the sum. It's a public method. It's a non-static method. We're going to break this down. We're going to look at the stack. We're going to make a call and verify the stack. Here we go. First, this is tail recursion. How do I know? Because the method, the call to sum, which is the same method I'm writing, is last. So this is tail, and it's called the recursive step. Base case is first. Generally, the base case happens with an if statement. If such and such condition happens, stop the entire thing. Remember, stronger break. Return is a stronger break. This is actually saying stop the whole thing. So when the base case is reached, our base case then is 1. Simpler version of itself. So I'm saying if I call this with a 1, the answer is a 1 because the sum of 1 is 1. But if I call this with a 2, it's the sum of 1 plus 2. If I call it with 3, it's the sum of 1 plus 2 plus 3. Call it with a 4, sum of 1 plus 2 plus 3 plus 4, and so on. So because 1 is the simplest version, then that's the base case. That's very important. So I'm going to call this method with a 5. So what's going to happen? Here's the stack. Let's walk through. On the right side, before we jump into the stack, I have a little formula here. So here's the rule of thumb for recursion. If you can avoid writing it, avoid it. Okay? Only if you absolutely have to do recursion do we do it. But this formula on the right side here can do this much quicker. For example, if I want to add up all numbers starting from 1, all integers, such as say starting from 1 and stopping at 5, the answer is 15 because I can say 5 times the next one. The next one would be 6. That's 30 and divide it by 2 and I'll get 15. That's a quicker way to do this. I could just simply do this formula and get the answer. But because we have to study recursion, we want to see how the stack works. That's the important thing. This is the magic right down here. So here we go. The method gets called sum of 5. The S represents sum. I didn't write the whole word sum, I just put an S. 5 gets called. So here's what happens. Is 5 a 1? No. Then return 5 plus sum 4. Sum 4, how do you get that? Well, n was 5 when I first called it. So if I take 1 off, it's going to be 4. So this is what happens. Pushed onto the stack. I have to make sure we get something clear here. This is upside down. This is the root. It's at the bottom. Consider this whole picture upside down. So this is on the bottom, like as if you're stacking books. Okay, like as if you're stacking books. That's the whole idea of the stack. So the first thing that came onto the stack was this. He's on the bottom. He says, no, don't return yet. Push. Sum of 5 plus S4. 4 comes in, back up to the top. So we came here, 5 plus S4. Came back, call itself. Is 4 a 1? No. 4 is not a 1. Can't stop yet. Push onto the stack. 4 plus sum 3. 3 comes back. Says, hey, is it a 1? No. Push onto the stack. 3 plus sum 2. Sum 2 comes back. Is it a 1? No. Push onto the stack. 2 plus sum 1. 1 comes back and it says, yep, you just hit the base case. We're going to return a 1. All right, those were the pushes onto the stack. Here comes the pop. Pop happens in reverse. We're going backwards. Since this guy comes back, he's returned a 1. So a 1 takes this place and the addition takes place here. So 1 plus 2 is 3. That means sum 2 is 3. So 3 replaces sum 2. I'm popping off the stack. A 3 goes here. 3 plus 3 is 6. That means sum 3 is 6. So a 6 goes here. And a 6 gets added to 4. And 4 and 6 is 10. So 10 goes here. Sum 4 is 10. 10 plus 5 is 15. That's it. That's how we get the stack pushed and popped. So when we push, we're coming down. And when we pop, we're going back up. Please keep in mind this is upside down. I draw it upside down because it's easier to do it this way. We could have drawn it the other way around, putting this on the bottom, putting this above it, this is above it, this is actually at the top. All right, I'm going to run this. So it's a non-static method, so I need an object to call it. And if you remember, the class is recursion, so I make an object, an instance of the class, then I call the method with 5. Let's run it. Answer 15. Let's check one more. How about if we do sum 3? Remember when we were popped off the stack, we figured out what sum 3 is? Let's kind of look at a simpler version of this. So if we look at just this tree, called a subtree, just from here down here, this would be the 1, add it, we get a 2, with a 2 I should say, and we get a 3. Then that 3 goes here, and 3 plus 3 is 6. So sum 3 should be 6. Let's try that out. Swap out the 5, put a 3, save, and run. Boom. That's it. First example of recursion with a stack, sum of consecutive integers. We'll do some more right after this.